Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Nick Merski. He's Vice President, Space Operations, Space Flight Industries. We're broadcasting from the floor of SmallSat Conference. We got all kinds of people walking by us. Today's podcast is about leveraging small satellite constellation capabilities to fuse data with high-resolution imagery. We will talk about satellite imaging as a service and a new rating scale, the Temporal Imagery Interpretability rating scale that will help others define and classify data and imagery being collected in new space. To discuss this, we've invited Nick Merski, who is the Vice President of Space Operations at Spaceflight Industries, where he oversees Black Sky Global, a subsidiary of Spaceflight, which aims to have a complete small satellite constellation orbit here in 2019. Well, Nick, we're going to jump right in here. This is a small satellite conference. There's a lot of new small satellite constellations out there. What is unique about Black Sky's imaging constellation?
Yeah, John, so I guess the first thing that I'd say is where there's been huge expansion in the space industry and the amount of space-based data sources that are out there, I think there's still a real set of needs and gaps in coverage and capabilities. For example, have you ever seen an image of the Super Bowl? No, because there are still fundamental limitations of when and where you can get access to space data. We're really trying to address that need with an interactive geospatial monitoring service that can provide users unique insights about a business need on a real timely basis.
When you say interactive, you have to worry about latency and communications and availability, so it's a lot more complex than just tossing a word like that, isn't it?
That's right.
So let's say we have a commercial customer and he signs up for high-resolution imaging services. So how quickly can they see the Super Bowl or the football game or what they're looking at?
And I think the key point in there is really the service-grade experience. Our goal is to really have predictable delivery timelines that are measured in minutes, not kind of the state of the current in terms of hours and even days, which still frankly occurs worldwide. So where we want to be kind of in the next year is consistent inter-hour service across all world markets. So 20, 30 minutes from collection to delivery.
So give me a typical customer. Would it be a federal customer, government customer, military? Would it be commercial? Sure. Give me a for instance.
Yeah, I think all the ones that you mentioned above, people that are really data-driven people, risk managers, people that are looking to speculate or track assets in a number of remote locations. All of those people need timely access to information and the ability to understand what's going on around them as well as use the domain of space to see from above.
Would agriculture be an application? Something like that?
Sure. Agriculture could be, and it's certainly one of the traditional markets. Our system is really focused on monitoring locations, and we've really focused on the temporal resolution of that. So we will have some agricultural applications, but we've also really focused on seeing one place on the globe many, many times. So, there's different value propositions there.
So you don't have to name any specific companies. So what is the latency today? What's the typical latency that most people encounter today?
So typical latency today and what's innovative in the market is less than 12 hours right now.
12 hours?
Yeah.
Well, a lot can change, can't it?
Yeah, so there's a lot to disrupt there still.
Your images, the Black Sky images, is either the latency or the resolution limited by technology or by regulations? So where's your bottleneck?
First off, the regulations really don't limit us either in the technology that we're trying to deliver or how fast we can deliver it. We have handling and storage requirements that are dictated by our license, but we don't have any holdback times that we need to adhere to. There are some regulations in terms of the resolution that we can provide data at, but our value proposition is well below that threshold, and we're really our offerings at around 1 meter. Image resolution.
So can you leverage cloud computing? It's a buzzword. A lot of people are using it, a lot of power there. Can you leverage it for your infrastructure, like image processing, analytics, ground systems?
Yeah, in fact, we've been a cloud-first company since we got started, and that's really helped us. our cloud, our user platform is in the cloud, our command and control systems, and our image processing pipeline, and in various parts of the cloud with various different types of security and information assurance controls. So we can really take advantage of the accessibility of the cloud and then also the ability to really secure it into kind of a closed network environment if you need to.
So spaceflight's been in business since around 2000, and Black Sky is just more recent than that, maybe.
That's right.
Like 2017, 2018?
So we've really started with our financing in 2014, so we've been around about 5 years.
So you can claim that you start off in the cloud too, because that's when it kind of gets popular, isn't it? Yeah. So are you taking advantage of any new commercial ground providers to get some growth in your business?
Yeah, we're really excited about the growth that's occurred in kind of the ground provider part of the market. Our ground architecture allows us to leverage different ground station architectures. So the emergence of those providers kind of gives us both optionality and different ways to procure services, which is exciting for us, and really kind of helps us in our goal to increase that level of service and product quality for our consumers. Kind of an example of that would be, how we leverage different antenna assets and being able to spin them up on demand with some of the emerging service models really presents nice opportunities and scalability of some of the business models.
You said that spin up demand. I remember 8 years ago I'd ask a system administrator to spin up a hard drive for me. It could take 3 days. It was like, you have to give them a pizza or something, and maybe it'd take 2 days. So you've got some innovation in imaging. You've got some innovation in handling your ground station. So where does the data go that you collect?
Yeah, so as I mentioned, we're a cloud-first company, so our image archive is located in the cloud. So as we collect it from space, we route it to the image processing portion of our system. It really does all the image processing, quality assurance, archival, and data, and then that's connected to our user platform, which sends notifications to our customers that the data is ready to either be delivered, or if there's a more systematic delivery mechanism that we have, like let's say to an EC2 instance or something like that, it will just happen.
Yeah, and the people who talk EC2 are the Amazon Web Services people, of course, and they would say compute. They wouldn't say process, they say compute. It's kind of a different vocabulary than it was years ago. It's just changing so quickly, it's hard to go. Nick, thousands of people from all over the world are listening to this podcast. We've had people walk up to us from all kinds of different countries and get pictures and try to subscribe. And if you're listening to this and you would like to get email alerts when the new episodes are available, go to Google and type in Constellations Podcast. They'll come right up in the Kratos Podcast. Give us your email and off you go. We'll let you know when other great guests like Nick come on board, and we'll talk about all kinds of exciting things. If you take a look at the satellite business in the last, maybe since 2014 when you started, it seems like a lot of organizations are offering data from a third-party platform for a fee, and I guess this is your strike zone, isn't it?
When we think about our product at Black Sky, our product isn't our satellites. Our product is the unique insights that our satellites and satellite infrastructure provide, combined with a lot of structured information about the world going on around us. So the platform's really the hub where that all kind of occurs and comes together in product form.
I taught English for a year, so now we got to delve in the world of acronyms and abbreviations and hard things to say. So we're going to talk about NIRS and TIRS here. So if you're listening, be very, very careful about this. One is NIIRS and one is TIIRS. So NIRS and TIRS. So back in the 1970s, way before you were born, I'll bet, in the 70s, Image Interpretability rating scale was developed. It's called NIRS, N-I-I-R-S. And it defined different levels of image quality and interpretability based on types of tasks an analyst could perform with images. The higher the rating, the higher the quality imagery. I think 0 to 9 or 0 to 10. The NIRS scale has become well-known and widely used tool to characterize the interpretability of satellite images and has provided imagery analysts and consumers of satellite imagery a simple, easy-to-use, and powerful tool to describe and share satellite imagery. So you're going to turn that upside down here, aren't you? You're going to come up with something called TIRS, T-I-I-R-S. This is the Temporal Imagery Interpretability Rating Scale. So can you explain this?
Yeah. Maybe I'd start by kind of talking quickly about why is NIRS widely useful. When I think about it simply, it provides tactile examples of what types of applications can be performed with a given image of a given resolution. And so if you think about that and then you extend it to temporally, the time and the persistence components of the data really add a new dimension of that and how the data could be evaluated or applied. or used contextually. So I kind of think about the tier scale, and I say it could be used kind of a couple different ways. The first one would be kind of defining what are the rates that you need to sample a given scene or area to draw meaningful conclusions about a thing. Or another way that you could really use a scale like this is use it kind of in conjunction with nears to understand how those nears levels might change if you had a different sampling rate, because the time component does give you a different aspect of information that can change interpretability.
And speaking of time, if the NIRS was developed in 1973, I mean, mobile phones, you need a pickup truck to carry a mobile phone around in 1973. The technology's changed drastically. It would make sense, and other aspects of the technology would keep up as well, doesn't it?
Yeah, absolutely.
When it comes to standards, I think of standards emanating from the NIST building up north of Washington, D.C., you know, all those PhDs in physics and talking about standards. And I also think about nonprofit organizations, maybe associations coming up with standards. And so your company, you're just going to boldly go forth and say, hey, this is the new standard. Are you working with other organizations, maybe public-private organizations?
I think that, you know, we're not trying to be the proponent or the owner of a standard. What we're really trying to do is think about different ways that people can consume and talk about a really different type of data with different attributes and have a kind of common language to communicate.
I think there is an observation service called Global Risk Dashboard, and it's tailored for some very specific interests. Tell us more about these specific interests.
I kind of mentioned that, you know, our user platform is the hub that brings everything together, and really the Global Risk Dashboard is one way of viewing our user platform. And really what we have is a very capable user platform that really can take unstructured information about a place in the world and a geography and events going on at a time and contextualize that and geolocate that. And connecting that with a very capable, taskable satellite network allows people who are interested in understanding the world around them and the data that's flowing around them through a connected world of devices, and then kind of immediately connecting that with the view from space allows people to do kind of a different type of risk management and have a different view of assets that they track. And really that's what that product's all about.
You know, I was thinking that there's some case studies now with healthcare organizations relying on social media to project out different infection rates and different types of diseases and where they originate, which, you know, you can only do it on a chalkboard a few years back, but now you can almost visualize it and say, well, look, this is exactly where it's trending, and they have some accuracy with these predictions, don't they?
Absolutely.
So, news, social media, how else does your platform kind of include anything else besides those?
Well, so another one that, you know, is just kind of the world of connected devices. So I'd offer one, you know, thinking about kind of weather and natural disasters. You know, we have a very extensive set of connected networks throughout the world that help us kind of sense and understand when something is going to happen. And so that when you overlay systems like that with news and social media, with geospatial resources, you can really get a full spectrum picture of what's going on at a place very rapidly.
There are people who are worrying about space debris, we know that. There are also people worrying about plastic and debris in the oceans. And I'm thinking about sensors in the ocean, so your imaging service could provide environmentalists information about Earth because of the advantage you have in space. It's kind of like one's following the other.
Working back and forth and queuing from those types of resources is exactly the type of architecture that we've built.
Well, in the last few years, we've hit waves with cloud computing, we've hit waves with IoT and cybersecurity challenges and all kinds of things going on here. So from your perspective, if you try to look out the next 5 or 10 years, what kind of challenges do you see in the satellite industry?
I think that, you know, there are still big challenges in terms of normalizing transportation, getting there, being there sustainably, and really kind of maintaining the services that we're trying to provide and to leverage space really effectively, you know, in an enduring fashion. But I think there's also a ton of opportunities. I look at kind of emerging companies with different ideas of how to leverage either the viewpoint from space or the access that space can provide, and you know, I'm pretty sure that we're going to solve this and that we're going to be continuing to exploit space pretty rapidly over the next 10 years in a number of different ways than we are right now.
Well, all the youngsters are talking about going to Mars. Maybe your kids will wind up on Mars. I don't know. My kids are maybe too old for that, but. So what about projecting way out beyond 10 years? I mean, is there going to be so much debris in space? Your kids may not get to go to Mars because of that?
No, I think that we'll have learned how to kind of manage and live in that environment, just like we have in, very densely populated cities throughout the world. And, I think we will. I think interplanetary exploration is certainly going to be there. And really, what we consider space in the domain is really going to grow over that time.
When it comes to public-private partnerships, I think of, I'm in the Washington, D.C. area. I've interviewed many generals and a lot of military types. And if you bring up the concept of ride sharing and innovative use of technology, they kind of pull back a little. I think what companies like yours are doing is you're so innovative. You're showing them new ways to accomplish things more effectively. And it's pushing that barrier and pushing with new public-private partnerships.
I think innovation in the business model is as important as innovation in the technology itself. And I think we've had the real opportunity to work kind of both sides of that over the last several years and had some success with that already.
Well, Nick, unfortunately, we are running out of time. I'd like to thank our guest, Nick Merski, Vice President, Space Operations, Spaceflight Industries.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.